Everyone, welcome to this newest video. My name is Johan, and together with me still is Jits Langedijk from NVIDIA.
Hi, yeah, good to be here again.
In the last video we talked about the, what is artificial intelligence? What is machine learning? What is deep learning? How do we apply it? How does a model work? How do you train or use a model for inferencing? And today we're going to talk about the architectures or the platforms that we could run those type of solutions on, and specifically from a data scientist point of view, because what we're seeing in projects is that companies like, or organizations like hospitals, but also financial organizations, they have data scientists working there to process their data, to analyze that data, and to apply that data in prediction of in case of a hospital, for instance, cancer prediction, or in case of banking, financial prediction if someone needs a loan or something like that. So, Jits, in terms of platforms.
Yeah, so as you said, a data scientist, whether that's a workload for high performance computing, HPC, or machine learning or deep learning, he or she requires lots of computational power.
Yeah.
Lots of resources. We got lots of data to process, as we discussed in the previous video. In the early days, there was not really a off-the-shelf solution for this data scientist. So
they built it themselves, right?
Yes, this was all white label solutions, whether this was a desktop with some consumer grade GPUs inside, or maybe also already some servers with GPUs inside. And some super fast storage, of course. But they basically build their own solutions to process all their data to get their HPC workloads or machine learning or deep learning workloads. So a couple of years ago, NVIDIA recognized this trend in different industries. And this was for us the incentive to build a purpose-built, optimized solution. And this was the DGX Station, the DGX-1, and later also the DGX-2. So these are these nice, gold, shiny, purpose-built solutions for the HPC, machine learning, deep learning workloads. Initially,
so it's basically a box, pre-configured, set up in terms of the type of hardware. So yep. CPU and GPUs are completely set up to work in an optimized way.
Yes, yeah.
And the same with networking, right?
Yeah. So let's take like a DGX-1 for example. So we got in the DGX-1 nowadays, we got 8 times a V100. We have 32 gigabytes of frame buffer. These 8 GPUs are also with some NVLink and NVMesh technology, all interconnected. So there's, from a functional point of view, one big super GPU.
Right.
So they can all talk to each other without using the CPU, for example.
They're interconnected through like a PCI switch, right?
Well, it's the NVLink technology, our own technology. So on top of that, we have an operating system. So in the HPC, the data scientists usually work with some Linux distribution. So we got Ubuntu on top of this hardware. And this is all pre-configured and fully supported by NVIDIA. So all the data scientists have access to our enterprise support as well, as long as you're working with a licensed solution, of course.
Yeah.
And now the real benefit for this data scientist is that you can also use the NVIDIA GPU Cloud, NGC. And just now everyone know where to find it. So the NGC, NVIDIA GPU Cloud, is as it says, a cloud resource repository where all the data scientists, but also you and me, of course, everyone can grab his pre-trained models, frameworks, different version of frameworks, pre-trained models, and all kinds of industry workflows that really simplify and increase the time to market for a data scientist.
So it's basically like a marketplace, and the only thing you need is an NVIDIA developer account, right? Which is totally free to sign up for.
Yeah, you create an account on the NGC. It's as you said, it's free, and as soon as you get that up and running, you create a security key. So now it's able to communicate securely with your physical or maybe your virtual resources. And what you do is basically you can pull down some, well, what we call the NV Docker containers. And this allows you to run a container with your framework and maybe your libraries and your runtime. And now all of a sudden your data scientist is able to, in a really flexible manner, get up and running with his setup within, I don't know, 4 hours, 5 hours or something.
Right.
So instead of building this white label solution all the way from scratch, working yourself through, I don't know, 100, 200 pages of documentation, make sure that you get the correct drivers installed into your hardware, into your or firmware, your drivers into your software. Maybe install your own Docker container, and to set this all up, it can take up to a week or 2 weeks. I don't know. It depends on the use case, of course. But then this is only for one type of framework to train one type of a model, and all of a sudden, your data scientist colleague next to you, he has to walk through the entire process. Well. Also on the same time, so there's not really a flexibility. And with the NVIDIA GPU Cloud, you have the option to do another pool for a different version for an NVIDIA Docker container. So this is it increases all the flexibility with your hardware. All of a sudden, all your data scientists can make use of the same hardware configuration, with its own frameworks or maybe its own models to train or to retrain. So this, like from Monday to Wednesday, you train TensorFlow version 1.4, and from Wednesday till Friday, your colleague is training with a different version of the same TensorFlow framework. So it's all about supportability, of course. You got a fully supported stack, optimized, and the flexibility to use all these containers on the same hardware, of course. Because when we're talking about NVIDIA Dockers or Dockers in general, we're talking about portability. So this data scientist can also start using maybe he still uses this old hardware with his I don't know, some Quadro boards, and he needs to step up and really work his way to production. But he already trained a small network or a model with a framework on his physical machine. So now he can pull his Docker container and reuse it on this DGX1 in this case, or maybe he or she has trained something in a public cloud. Of course, we have lots of GPU resources in all kinds of different public clouds, and maybe you start off with training over here, and as soon as you have the results that you're looking for, you can take your container, let's call this container C, and put it on your DGX. And now all of a sudden, because you have maybe your big data set over here, you can use the pre-trained model and use it on within your own infrastructure with your much more bigger data set, of course.
And to continue training.
Yeah, to continue training, because it's a continuous process, of course, in most cases. So of course we're talking about a physical solution with the DGX appliances, of course, or a public cloud solution where you can use GPU accelerated resources, and they all are compatible with the NVIDIA GPU Cloud. But of course, you know even better than I do, of course, there's a whole world of virtualization as well. Yeah. Of course, we are aware that next to a physical world, we can also use the hypervisor layers.
Yeah, and that's a great segue because what we're seeing nowadays is that a lot of customers are implementing technologies like PKS, so Pivotal Container Service, or what's being expected in the first quarter of this year is Project Pacific by VMware, which are container orchestration and container deployment technologies. And it would be great if we could use the Graphics Cloud containers in container management solutions like that, and benefit from the GPUs as well. So we have a couple of flavors in doing so, and let's start like Jits drew there, a host, and this is in this case an ESXi host, and that host contains your average or your normal resources. So that's a CPU, that's a RAM, that's a disk, and that's networking. And when we talk about GPUs, like a couple of years ago, in the data center, we always talked about VDI. So there was a GPU on top of that, mostly just one or a couple of them, and those were capable of both encoding video streams as well as rendering those videos. So what we now see is that those GPUs, and that could be a couple of different models, but if we're talking about computation, we basically talk about two models, a T4 and a V100.
In essence, of course, we got Quadro GPUs and Tesla GPUs, and the Quadro GPUs, these are the GPUs that you typically would find in a physical workstation.
Yeah.
So these are the boards actively cooled with display outputs, and in the data center, like in your ESXi host, you can find all the Tesla GPUs. So, and of course, well, we see a lot of T4s or V100s being applied there, and you're going to explain why you use those two, of course. But there are multiple different flavors as well that can be used in the data center. And also nowadays we have two RTX boards, so two Quadro boards that can be used in the data center as well. So like the RTX 6000 and the 8000. But continue with the T4 and the V100.
So we see as ITQ, we see those boards being used the most when talking about computational workloads. And so we have these cards, and on top of that we have the hypervisor and hypervisor, as well as the GPU manager, vGPU manager.
Yeah, the vGPU manager, which is installed into the hypervisor with ESXi in this case.
And these two basically distribute or pool the workloads and schedule those resources based on the VMs you run on top of that. Now, when talking about those containers, you need to run those containers on a platform. And in terms of when we're talking about PKS, as that is a current technology, we run VMs with a certain operating system. In this case, let's talk about Ubuntu, because we talked about Ubuntu there as well. And we have a couple of them, Ubuntu VMs. On top of this is where we can deploy and download those Docker containers. So we talked about Docker container A, B, and C, and that's exactly what we're doing here as well. So we have A, we have B, and we have C.
So these Docker containers run within the Ubuntu virtual machines?
Absolutely. And when we zoom a little bit into how this basically works, is that we have the VM, which runs Ubuntu. The Ubuntu VM itself has Docker installed, so that's both Docker as well as NVIDIA Docker. And that VM is able to run those containers on top of that VM. So that VM has a vGPU installed. And we know from the different types of deployments that are possible within NVIDIA vGPU that specifically for graphics output, you would ideally work with either an A, B, or Q profile. whereas A and B are mostly used for your normal use cases or remote desktop services, and your Q profile is mostly used for quadro acceleration. So that's your high performance graphical use cases like graphical designers, but also capable of running your computational workloads. But there's a fourth profile, and that's the C profile for vCompute Server. And what we do with that C profile is that we link a certain amount of video memory from the physical GPU to that VM. Let's say a T4 has 16 gigs of frame buffer, so we can attach a 16C profile to the VM. So it has 16 gigs of frame buffer. It fully allocates the whole GPU in terms of the uses. And in this case, the Ubuntu VM is able to utilize those GPU resources for those individual Docker VMs.
Yeah, you could even go with multi-vGPU where you assign multiple physical T4s into the same virtual machine.
Yeah.
So that's another option when you need more GPU computational resources. You can assign multiple vGPUs to kind of similar where we have 8 V100s here in a DGX1. In this case, we have 2 T4s for one virtual machine with a NVIDIA Docker container running.
Yeah. Well, and it's great that you mentioned that. And okay, so we talked about how to deploy a vGPU profile to a VM that is capable of running NVIDIA Docker files, so pulled from the NVIDIA Graphics Cloud or GPU Cloud. And so in a host we have in this case the choice over 2 different cards, a T4 and a V100, the cards that we see the most at customers that do computational workloads. But why would a customer choose a T4 over a V100 and vice versa? I think the biggest difference between these 2 cards is that a V100 supports double precision computations, while a T4 doesn't do that. So if you require that, if your models or your HPC computing requires...
Specifically in HPC, we see a lot of demand for double precision.
Yeah, so then a V100 is your best choice. But in other cases, we have a choice. And if you look at the workflow that we have as a data scientist, we start to develop a model which will be trained with maybe a smaller data set. Then we end up with an output which has a certain degree of success, and you train it with. So this is with a smaller data set. This is trained with a larger data set. Larger, and at the end we do inferencing. When looking at that different workflow, I can imagine that if we take a VM like this with profiles like this, that the development of that model could easily be done on a card like this. It's capable of handling the same types of models, the same types of. You can develop the same types of models, but when training, they'll probably perform pretty well because you're training your model with smaller amounts of data to test out if the model works. You don't want to train a newly configured model for, let's say, 4 to 5 weeks because that takes a lot of time. But when you have a certain output with a certain prediction that is what you're aiming for, then you're going to train it with a larger data set. And that's, I think, where another difference between the T4 and the V100 exists, because your T4, like I mentioned, has 16 gigs of frame buffer, while the V100 has 32 gigs of frame buffer. Also, the amount of CUDA cores between the T4 and the V100, tensor cores between the two, is different. So the V100 has much more computational power, and especially when having a pre-trained model or having a trained model with your first data set, and you want to expose that model to your production or your bigger data set, you would ideally do that on a card like a V100. If you have a trained model, then if it's perfect to use in your production environment. In the inferencing phase, you could perfectly do that on a less powerful card like the T4.
Yeah, and as you said, basically with the NVIDIA GPU Cloud, you can deploy these containers on physical machines, on public cloud, or maybe on a virtualized environment. So you have all the flavors available to you, and you can deploy your framework or train your model, maybe starting from a physical PC, using an NVIDIA GPU container on a physical PC with a Quadro board, and maybe transfer it to a DJX, or maybe you start training in the public cloud, or maybe if we still make to emphasize that you can also use a virtualized environment and use some VMs, or maybe you can have some VMs with a Docker container inside with all your libraries and your runtime. You can deploy them everywhere. Just to make sure that everyone has all the simplicity to deploy your HPC, AI, machine learning, deep learning workloads, so that you can innovate much faster and you have the flexibility of all these different flavors to run your workloads.
And we're talking flavors, and that might be, it's a fun thing, but you're even able to download those containers or to pull those containers on like the small edge boards that NVIDIA developed, like the Jits and Nano, or the more powerful board, the Jits and Xavier. And I think, if you would like to play with all this, it's a great starting point, as well as a Deep Learning Institute by NVIDIA, which you can find through this URL. You can sign up there for free, and you can run some deep learning trainings, like how to create your own model, how to test it on a Jits and Nano. I highly recommend running any of these trainings if you're interested in a topic that I think everyone in IT will one day, or today or tomorrow, will come across that topic, and it's a really great resource if you want to know more about the NGC as well.
And especially if you, the Deep Learning Institute, as you mentioned, also when you're not aiming to be a data scientist or a domain expert on a certain topic, but it's very nice to understand what kind of technology is being used with the products that we use in our daily life. So maybe it's us being geeky, I don't know, but it's always nice to understand what is happening behind the scenes when you're using, like for instance, a neural language processing. Yeah,
absolutely. Cool. Well, Jits, thanks again for being here and to explaining everything related to the NGC and how to set up or how to deploy that in the I would say the GPU platform that NVIDIA offers, with both physical as well as virtual as well as edge kind of devices. Thanks so much for watching, and we'll definitely see you next time.
So if you enjoyed this video or any other video of ITQ Lightboard sessions, subscribe to the channel.
Do it now.